2, just remembering that if you have something of this form, x squared equals 4ay or y squared equals 4ax, that means that we have a parabola whose vertex is at the origin. And based on the value of a, we know that the parabola either opens up, down if it's x squared in the equation. If it's y squared, it's going to open left, right, depending on if a is positive or if a is negative. So we're going to take this idea today and eventually get to a point where we extend this outside of the vertex being at the origin. What I think would be just a good quick refresher for you is to see if you can sketch these two parabolas, x squared equals negative 12y and y squared equals 8x. I'm going to show you my answers to these, along with the coordinates of the focus, directrix, ends of the LR, those things that I've been listing. So if you want to hit pause, go ahead and try it, and then I'll show you my sketches. That works, I think, well for this question. So here are the solutions here. Those are the values of a that I calculated, because remember the coefficient is 4a out front. Here's my vertex, focus, directrix, and ends of LR coordinates. Remember that sometimes it's almost nicer to plot it on the graph and then use the graph to be able to determine some of these coordinates. But here are my sketches below for the two parabolas in question. X squared is going to open up, down, right? And remember, if a is negative, it's going to open down. Y squared is opening up to the right in this case because a was a positive number. So hopefully we did well with those sketches. What we're now going to talk about is working backwards. So I'm going to start a new section of notes here titled Working Backwards. And what do we mean by working backwards? We mean if I gave you some information about the equation of a parabola, could we write the equation? And today's focus, I'll tell you, will be we're working still with our knowledge of the vertex being at the origin. So if the vertex is 0, 0, and I tell you the focus is 3, 0, what do we need to know to write the equation? Well, we're going to need to know the vertex always. Today, we won't really focus on that too much because, like I said, it's just going to be origin for now. But then the other things that we need are we need the value of a, and we need to know which way this parabola opens, because the way that it opens is going to help me determine if it's an x squared equation or a y squared equation. And even I think just plotting the information that you're given, you don't have to make the whole sketch if you don't want to. But the focus at 3, 0, the coordinate 3, 0 would be 3 units to the right here. And something that I don't think I mentioned in video 1, but something I like to think of is that I almost think of the parabolas being a little Pac-Man. Now, I know Pac-Man's sort of a dated video game, but I'm sure you can all imagine the reference, and I feel like you've probably all seen Pac-Man somewhere. So it's a little Pac-Man, and I think of the Pac-Man as the parabola. And what does the parabola want to do? The parabola wants to eat the focus. So if you think of it in the context of the parabola wanting to eat the focus, okay, that was my little Pac-Man there, then we know that this parabola opens up to the right. We also know that the value of a in this case is 3 because a is the distance from the vertex to the focus. So if we know the value of a, we know it opens up to the right. This equation should be y squared for opening up to the right, for being sideways. And just remember that the number up front has to be 4 times the value of a. So if a is 3, it's going to be y squared equals 12x. And that's it. So that was actually a pretty quick one to get started here. If the given information was that we had a directrix at y equals 2, and again, we'll keep the vertex at the origin, how would we write the equation in this scenario? So graph the line y equals 2. So here's the line y equals 2. Here's my vertex. So what we should have hopefully become accustomed to by now is that the parabola will never cross the directrix line. So in this case, if I don't want to cross the directrix, I know that the parabola has to open down. And just like the value of a is from vertex to focus, like we had in this one up here, the value of a is also the distance from the vertex to the directrix. Now, even though that distance is a length of 2 units, because it's opening down, it might be useful for you to write that a is negative 2, because we know that the value of a will be negative in this scenario. So since we're opening down, it's going to be x squared. 4 times a would be negative 8, and that goes next to y. Okay, let's try one where we know the length of the LR, length of the lattice rectum. LR is 10, the vertex is 0, 0, going to tell you that this opens up to the left. If I didn't tell you to open up to the left, there wouldn't have been enough info exactly to get the correct equation here. But remember that the equation for the LR in general is it's the absolute value of 4a. So knowing that this number represents 4a there's not really a lot of work to do then, because that's the number that has to go into the equation. And if it opens up to the left, I know it's a y-squared equation. Remember that opening up to the left means that a had to be negative. So why is this a positive number for the length of the LR? Because it's a length. We took the absolute value of it. So the end equation should be y-squared equals negative 10x. It's probably pretty easy to forget that negative next to the 10. But remember, opening up to the left means that the value of a should be negative there. All right, let's do one more of these, and then there'll be some practice on the homework that you'll see just like it. Okay, this is a parabola whose vertex is at the origin, has x-axis symmetry. So we'll talk about what that means in a moment here. And we know the parabola passes through the point negative 3, 6. Okay. So just kind of a rough sketch so we can visualize what's going on here. So here's the vertex at the origin. The point negative 3, 6, let's say, is somewhere up here. Left 3, up 6. You can imagine that to graph a parabola that has this point on it and has this vertex, the parabola could either open up and go through that point, or couldn't the parabola also open up to the left and contain that point? So how do I know which one it is? Well, the important piece of info that we needed to be able to answer this correctly is that it has x-axis symmetry. So if you draw in a kind of a dotted line, that's the line that's going to cut the parabola in half, which therefore means that this parabola opens up to the left. So without that fact, it could have opened up through that point or to the left, but since it has x-axis symmetry, we know it opens up to the left. So the equation of this one's going to be something with a y-squared in it, right? That's kind of the standard form for a vertex at the origin there. So how am I going to figure this out? Well, I'll tell you what students incorrectly assume is that this is one of the ends of the LR, the lattice rectum. But we don't know that, right? So if we were to actually draw in this line here, would that contain the focus? Is the focus really 3 units in? We don't have enough info to determine that. So the way I'm going to have you approach a question like this is to figure out what A is. Can we actually just simply plug in this for X and this for Y and solve for the value of A? So in this case, if Y is 6 and X is negative 3, we get that 36 equals 4A times negative 3. Could we multiply the 4 and the negative 3? Absolutely, but maybe I'll convince you we don't need to. Because remember, what we're trying to replace in our equation is we're trying to replace the number 4 times A. So even though A is definitely negative 3 in this case, if you know that 4 times A is negative 12, you can stop there and replace that whole quantity with negative 12. It's really up to you. If you got A equals negative 3, well, then you're just going to have to multiply it by 4 again when you put it into the equation here. So just to go back to this thought, was this an endpoint of the LR? And it turns out in this scenario that actually it was. Why do I know that? Because remember, if A is negative 3, if I go 3 to the left, that's the focus. So if that segment that I connect down goes through the focus, then these are the endpoints of the LR. And the LR would have a length of 12, which corresponds with this value right here. But did it have to be an end of the LR? Not necessarily. So whenever you see passes through a point, start with your sort of standard form. Plug in the values for X and Y and solve. Okay? All right. So the next thing we're going to do today is beyond working backwards. We have to move away from the origin a little bit. So let's start talking about graphing with a vertex at HK. Okay, so if the vertex is somewhere else and not the origin, the two new standard forms will be x minus h squared equals 4a times y minus k. And the other standard form would be that y minus k squared equals 4a times x minus h. Notice how the k always stays with y and the h always stays with x. It just depends on which of those quantities is squared to know how is this parabola going to open. If the x is being squared, we know it's up or down, and that will be dependent on if a is positive or negative. We know if y is being squared, it's going to open up to the right or open up to the left if a is positive or negative. Okay, let me give you one that's a nice one to start off with. X minus 2 squared equals -4 times y minus 3. If I want to sketch this parabola, the first thing I want to start now by thinking about is what are the coordinates of the vertex? So we haven't had to think much about that up until this point because the vertex has always been the origin. But if the vertex is at hk, and this is x minus h and y minus k, just like we do with circles, the vertex in this case is going to be the point 2, 3. I'm going to write down two more things. I'm going to write down the value of a, and I'm going to write down which way this opens. Because once I have that info, I can actually start plotting this pretty quickly. The value of a is going to be -1, because remember, this number is 4 times a. So if I divide that by 4, we get this value of a. And I'm hoping you're saying that this would be opening down. Two things tell me that. X is being squared, so it's going to be up or down. If a is negative, we open down. So when I go to start making my sketch, I know that the vertex is up in quadrant 1 at the point 2, 3. So you don't have to be super specific about this, guys. I'll try and be a little bit specific about my scaling here, but again, I really need to get myself some graph paper to make this look a little bit nicer here. There's my vertex at 2, 3. If it opens down, then at 2, 2, there's my focus point. So if you want to come over here and list that, the focus is at 2, 2. It's one below it. If you go 1 unit above the vertex, this line right here, the directrix, would have the equation y equals 4. And then from there, the last thing you have to do is determine that the total length of the LR has a length of 4, which means if you go 2 to the right of the focus and 2 to the left of the focus, which actually would be right on top of the y-axis here, those are the ends of the LR. So the ends of the LR would be the point 0, 2, and also the point 4, 2. And that's a complete sketch now. So nothing too crazy in terms of finding all the critical info, right? It's the same idea as if the vertex is at the origin. It's just not as many zeros in our coordinates anymore. Okay, if I gave you something like y squared equals 8x plus 8. Okay, if I look at the standard forms up here, it almost matches this y squared form. Except I don't see the x minus h part isolated over there. So what I'll say is that if you do not have a quantity x plus or x minus something in parentheses there, then you have to factor out whatever the coefficient of x is as a GCF. So if I do y squared equals 8 times x plus 1, that quantity, now I can clearly identify the vertex. Be cautious about the vertex here because you have to get the x value of the vertex from where the x's are. So the x coordinate of the vertex will be -1. Since there's no y minus k value here, we know that the y coordinate of the vertex is 0. The value of a in this example would be 2, right? Because if that's 4a, divide that by 4. And this graph is going to open to the right because the value of a is positive. Okay. So, I hear crying in the other room. This is not good. Okay. I might have to check that out in a second, guys. Okay. So we're going to start with our vertex right here at -1, 0. We're going to go 2 to the right. That's going to be the focus. And then if I go 2 to the left, sounds like the crying child might be coming my way. We'll see. All right. The focus is the coordinate 1, 0. The directrix is this vertical line, x equals -3. What's wrong, crying child? What happened? You hit Avery? That's not nice. Did you say sorry? I'm sorry. Okay. All All right, go back in and watch that movie, guys, okay? Go ahead, Avery. You can go back in. Be nice, Mason. Okay. Directrix is at x equals -3. We need the LR length. LR length is a total length of 8, which means if I go up 4 and down 4, I'm just going to estimate this real quick, guys. I'll pretend like this is up 4 and down 4, something like that. Okay, that we get this right here. So the ends of the LR from the focus at 1, 0, we went up 4 and down 4. So we've got 1, 4, and 1, -4. Okay. Also, probably not so bad to get started on that one. We're going to try and do 2 more. We'll see how this goes. All right, Avery, why are you still crying there? What's wrong? Do you want to go watch a movie with Elodie? You need an ice pack? Okay, I'll get you one in 1 sec, okay? Go watch the movie with Elodie, okay? Thank you. I was just gifted Mr. Potato Head here, guys. She's missing some eyes, but okay.
Guys.
Yes, thank you. All right, hold on. I just got to do 2 more questions really fast. Okay. This one's going to be a little bit more intensive to get into standard form to get started because I'll tell you we're going to have to complete the square. So whatever the squared variable is, keep that on one side and then very carefully move these terms to the other side. Go ahead and try that while I'm helping Avery. She apparently needs some help. Okay. All right. Let me get you the nice back.
I want that purple ice pack.
Purple one here. This one? Okay. Okay, we got the purple ice pack all set. All right, so go ahead and, like I said, move those terms to the other side. So -16y -4. Now we can complete the square. So whatever I add to complete the square for the x's, I have to add it to the other side. 4 divided by 2 is 2, squared is 4. Okay. So it's not very common that these numbers will cancel each other out, but they do in this scenario. In standard form, this would be x plus 2 squared equals -16y. So this one has a vertex at -2, 0. Value of a is -4. And it opens down because of 2 things. X is being squared, so it's an up or down equation. If a is negative, it opens down. So if I start at -2, 0, there's my vertex. If I go down whatever 4 units is, I'm just going to estimate that and call that the focus right there. So that's going to be the coordinate -2, -4. Yeah, it's not broken. It's okay, buddy. Okay. If I go up 4 units, that's going to be the equation of the directrix line. So the directrix is going to be 4 above, so that's y equals 4. The LR has a total length in this case of 16. I'm talking to some students here. You can't be loud, okay? Okay. All right, so if I go 8 to the right and 8 to the left of the focus, that's going to get me to the ends of the LR. So the ends would have the coordinate.
Look over here.
If I go 8 to the left, that's going to be -10, -4. If I go 8 to the right, that's going to be +6, -4. So it's going to be something, and again, this is just an estimate, guys, since I don't have graph paper. It's going to be something that looks like this. If you want to get fancy, and I'll be getting fancy for the ends of the LR in future units, so you might want to get on board with this. From the x value of -2, this x value right here, what did I do? I added and subtracted 8 to get to the ends of the LR. Okay, y value stayed -4. So that's kind of a fancier way of writing those coordinates all in one combined format. Okay. All right, Elodie and Avery, can you guys go in the other room? I'll be there in 1 sec. I'm making a video and I'm almost done. I got 1 more to do. Okay.
But Mason bumped my head.
I know, Mason bumped your head. Yeah, I knew I was taking a risk pre-calc by doing this video while my children were all still awake here, but we're going to try and finish it up real quick. All right, for this one, let's go ahead and start the same way. So keep the y's together on this side this time. Subtract the 8x and add the 28 over. Okay, careful when you move those terms over. It's easy to make a sign mistake there. Okay. Value that completes the square is 4, just like we had in the last one. So add 4 to the side as well. Notice how those 4s don't cancel each other out like we had in the last case. This becomes y minus 2 squared equals negative 8x plus 32. Okay, and finally the last. Okay, hey, no yelling. Okay. All right, last step is take out that negative 8. When you take out a negative 8 as a GCF in this case, guys, you have to be cautious that taking negative 8 from 32 makes that a minus 4. So just make sure you're paying attention to that. So the vertex in this one becomes the point 4, 2. Make sure you get the x value from the x's, y value from the y's. The value of a is negative 2. It's going to open left because y is squared and a is negative. So if the vertex is over here at 4, 2, right 4 up 2, opening to the left, if I go 2 units to the left, here's my focus at 2, 2. If I go 2 units to the right, the directrix would be at x equals 6. Very rough sketch here. Okay. The LR has a total length of 8, which means if I go up 4 and down 4, we'd be here and here. The ends of the LR, I'll write them separate, and then I'll show you what they look like in fancy form. If you add 4, you'd be at 2, 6. If you subtract 4 from the y, you'd be at 2, negative 2. The other way to think about that in the fancy form is from the y value of 2, we added and subtracted 4 to get to these coordinates. If you really don't like that fancy way, not a big deal. You should probably connect them to the vertex though, make it a complete graph. And I should probably end this video before my children hurt each other anymore. All right, so hopefully you got through all that today. Let me know if you have any questions.